start the class now.
Hmm.
Okay. Today we'll start from curvature. Last day we are over up to slope, then comes curvature. You can say curvature is nothing but the slope of the slope. That means slope explains how the curve changes, the rate of change. But the curvature explains how that rate of change behaves. Whether the rate of change is at an increasing rate or the rate of change is at a decreasing rate. As you know that slope is the first order derivative, then if curvature is slope of the slope, that means we have again take the derivative of first order derivative. That will be second order derivative of the function. Next ones. Okay. Curvature is of two types. One is the function may be a convex function or may be a concave function. What is a convex function? If the second order derivative is positive, that means the rate of change is at increasing rate. So then we say the slope is convex, as we are doing in case of total product curve. Let me draw the total product curve. This is TP. So initially what we are doing, initially TP starts from origin, but it starts at an increasing rate, then starts at a decreasing rate. Listen, at this point, look at the point. Before this point, you can see that the curve is, the shape is, you can say this shape is called as convex shape. After the point A, onwards A, this is a concave shape. Why? If we look from O to A, look at the curve. If you find how the curve is changing at the initial point, as we increase in goes on increasing more and more amount of labor, the total output no doubt increases. But at an increasing rate, it is increasing. That's why this is the shape, convex shape. Up to a certain point, when I increase my labor, no doubt my output will increase. But to what rate? At a diminishing rate. To understand this, look at a diagram. Suppose this is my TP. Initially, labor is 1, 2, 3, 4, so on. First, look at the increasing rate. One is first labor, suppose a TP is 10, then it's become 20, then it's become 30. So what is happening to the rate of change? From 10 to 20, the rate of change is equal to how much? 10. Again, from 20 to 30, the rate of change is 10. That means the rate of change is constant. No change in second order derivative. But if suppose the TP will be like this, first is 10, then it become 20, then it become the 40. Look, 10, 20, 40 increasing. But rate of increase, first 10 to 20, it has increased by 10 amount. Then 20 to 40, it has increased by 20 amount. That means the rate of change is also increasing. First it increased 10 amount, then increasing 20 amount, then may increase by 80, we'll say increase by 40 amounts. So rate is not the TP is increasing, but at the increasing rate. In that condition, we'll say that it is a convex shape, like this shape as in the diagram, in this diagram, convex shape. That is from 0 to A of the point. And the rate of increase can be like this. Suppose TP, first it is 10, then it's become 20, then it's become 25. Here, the rate of change, first it increase by amount equal to 10, then increase by the amount equal to 5. Here, TP is increasing, 10, 20, 25 increasing. So what is happening to the rate of increase? First increase by 10, then increase by 5, next may increase by amount 3. The rate of change is falling, 10, then 5, then 3. So in that condition, the shape will be like this, the concave shape, this concave shape, which occur in our diagram after the point A. This is the curvature, how the rate of change is changing as an increasing rate or decreasing rate. Just remember, if the rate of change is increasing, we say that the shape is a convex shape. The convex shape that is seen in this diagram, where I put the tick mark, convex shape. What is happening here? In mathematically, we say if the function of the curve is convex shape, that means its second order derivative should be positive. Second, if we say that the shape of the curve is concave, in mathematically we say that its second order derivative is less than 0. This is all about convex and concavity. Then let's go. Do some example. Given the function f of x equal to 2x square plus 4x plus 1.
Ma'am,
The question is,
Can
Yes,
you
yes.
repeat for concave shape, ma'am? Second order
Okay.
derivative.
Okay, concave shape. Look at the diagram here. Where mentioned the slope is concave. What is happening here? It is just equivalent to take the example is like it is increasing. No doubt the curve is increasing. But what rate it is increasing? First, suppose in our you can say it increased by from A to B. Let me do the diagram here. Suppose here at point A, not indicated. Okay. Suppose in the diagram, this point is point A. When I move from A to B, suppose Y change by 10 units. Then I increase from B to C, Y will increase by 5 units. Again, it will increase by 2 units. The rate of increase is falling. As increased by 5 units, then 2 units, then 1 unit, so on. In this, look at my earlier example, this TP. Initially, my TP is 10, then I use additional labor, my TP become 20. Again, I use additional labor, my TP become 25. Then my TP become 28. So it is clear that my TP is increasing 10, 20, 25, 28, increasing. It is clear it is increasing, but to what rate it is increasing? That is when it increased from 10 to 20, how much it increased by? By amount 10, because 20 minus 10 equal to 10. Then I use additional labor. So what happened my TP? It increased from 20 to 25. But here, to what rate it changes? It 20 increase 25 minus 20 equal to 5. Okay, so initially it changed by amount 10, then it changed or increased by amount 5. Further TP increased from 25 to 28. But to what rate? That rate or amount is equal to 3. So TP is no doubt starting from 10 to 28 increasing, but at a diminishing rate. That the rate is 10, then 5, then 3, so on. That's why I'm saying its rate of increase is diminishing. As we say in the production function, it's the second stage of production.
Okay,
After this
ma'am.
point A, TP is increasing. But look at the shape. Before A, it is the convex shape. After A, it is the concave shape. How to distinguish? Look at this. The convex shape indicates what? The curve is open towards, is opposite to the origin. In this diagram, this is the origin. It is its open side. It is opposite of the origin. But in this diagram, this is the origin. It is inwards, in open inwards. Or you can say origin or x-axis. Clear?
Yes, ma'am. Ma'am, what about the first order derivative?
First order derivative will say whether the function is or the curve is increasing or decreasing. In this, all the conditions I find the first order derivative will be positive. Why? Everywhere in this condition, TP is increasing. Here, TP is also increasing. In third condition, TP is increasing. Throughout the area, I can say my TP first order derivative is positive. But in the first condition, the rate of increase is constant. That means second order derivative equal to 0. In second case, TP is increasing, but rate of increase is it is increasing at an increasing rate. That means second order derivative is positive. In third case, TP is increasing, so first order derivative will be positive, but the rate of increase is falling. So second order derivative will be less than 0. Below diagram, that is better will understand because it's showing different combinations. When I go
Okay,
to
ma'am.
the slide, you will better understand. Okay, ma'am?
Yes, ma'am.
Let me go to that slide. Okay, first let's do some examples, then we'll go. Shall I do the examples?
Yes, ma'am.
Okay, here. It's given the quadratic function, y, the hash bar equal to 2. That's why here the f of x function is a quadratic function. He said find out the first order and second order derivative. For the first order derivative, find derivative of 2x square plus 4x plus 1. Here, as you know that a person, so which rule I should apply here to find the derivative? Which rule I should apply here? Can anyone say derivative of 2x square plus 4x plus 1?
Coefficient of variable
This
of
is
a
the
function.
no. First rule is additive rule. Derivative of a function which is addition of suppose f of x plus g of x. Its derivative will be equal to take the derivative of individual function, then I will add them. Like take the derivative of 2x square, that is equal to 4x. Derivative of 4x will be 4. Derivative of 1 will be 0. Add them 4x plus 4 plus 0, that is equal to 4x plus 4. First the
Okay.
additive rule. Then I take x to the power n formula. Okay. It is the first order derivative. Suppose if I say that the value, if I take the value of x, in this condition, the first order derivative equal to 4x plus 4. If like the value of x, if the function is greater than 0, that means this is a increasing function. Okay. First order derivative will say whether the function is a increasing function or decreasing function. If the first order derivative, that is f dash x, is positive greater than 0, that means the function is increasing function. That means if x increases, y will increase. Or if x falls, y will fall. First order derivative positive means both variable, dependent and independent variable, will move in the same direction. If the first order derivative, that is f dash x, is less than 0, we say the function is a decreasing function. Decreasing function means if one variable increases, then other variable will fall. In the reverse direction, xy will move. So that's why in the first case where f dash x will be 0, greater than 0, the curve may be like this, upward sloping. Look, your x increases, then y will be automatically increase. Both are moving in the same direction. Or you can say if we move from point A to point B, I say as x falls, y is also falling. The first order derivative indicates that the both variables are moving in the same direction. Ultimately, the
Uh,
graph will be
may,
increasing function.
Ma'am, we can say it in a law of supply case. When
Yes,
price
law of
increase,
supply first order derivative is positive. Because if price increase, quantity supply will increase. If price falls, quantity supply will fall. Both variable moving in the same direction means the diagram, the graph will be upward sloping curve. That's why we say the function is increasing. Okay. Reverse is the case for decreasing function. Like our example is demand function. Here, if we plot the demand curve, we'll find a downward sloping curve. That means if one variable, that is price increase, if the price increases, then quantity will fall and the vice versa. So if we find out the first order derivative, it should be negative. Okay. Now find out second order derivative. Second order derivative means take the first order derivative of once take the derivative of the first order derivative. So my first order derivative here is 4x plus 4. I have to take second order derivative means take this 4x plus 4, it's another derivative. The derivative of 4x plus 4. So derivative of 4x will be 4 and derivative of 4 will be 0. The answer will be plus 4 plus 0 equal to 4. Okay, so I think first order derivative and second order derivative is calculation is easy. There is no difficulty here. Here we say whatever may be the value of x, look at its second order derivative f dash x, which is equal to 4. If that which is free from x, that means whatever may be the value of x, second order derivative is always positive. If always positive means what will be the shape? Shape will be convex shape. Convex shape means like this. The curve is like this. Convex shape. In this case, second order derivative of the function is positive. Whatever may be the value of x, second order derivative is positive. That's why the function is convex shape. Okay. Then comes. Oh, it is not moving. Okay. Here, Sangeeta madam, you are asking the positive first order derivative, second order derivative. Just remember this box. First order derivative positive indicates it is a increasing function. If first order derivative is negative, it is a decreasing function. Clear? Then come to second order derivative. If second order derivative is greater than 0 or positive, we say it is a convex function. If second order derivative is negative, we say it is a concave function. So now say first order is your case 1. First order derivative is less than 0. That is negative. So the curve should be a downward sloping curve. Then if second order derivative is positive, that means the curve is a convex curve. So what will be the diagram here? In case 1, the curve may look like this. It is a downward sloping but convex to origin. Convex means convex to origin. So this shape will be like this. It is case 1. Case 1. Okay. Now look for case 2. What is case 2 is saying? The first order derivative, it is positive. Positive means it is an upward sloping curve. Then second order derivative is also positive, means it's convex. So it should be like this. You can say like this. Oh, like this. Okay. It is an increasing function because as the value of x increases, y is also increasing. So first order derivative is equal to positive. But the shape is concave shape. Okay, the shape is convex shape. Convex towards origin. This is the convex shape. Is it clear when if I say the diagram is convex, can you picturize it in your head? Convex, concave. Here. This is convex because the curve is open just opposite of the origin. But the curve is concave. The curve is open towards the origin. Okay, this is convex and this is concave. Clear? When I say convex, just remember this picture. The curve is opening opposite to origin. When I say the curve is concave, the curve is opening towards the origin. Clear? So come to our second case. Look, it is a increasing function, partial derivative positive, satisfied. Then it is a which open opposite of the origin. This is the origin. This is the origin. It is the opposite outside of the origin. So it should be convex shape. Clear?
Yes, ma'am.
These two diagrams are clear.
Yes, ma'am.
Okay. Then come to third case. Here in third case, it is saying the first order derivative is positive. That means it should be a upward sloping curve. The second order derivative is less than 0. That means it is a convex shape. So how should the diagram look like? It may look like this. Suppose case number 3. So it should be increasing function and concave. So it should be like this. It is open towards the origin of the x-axis and increasing function. Is it clear?
Yes, ma'am.
I say this is an increasing
Yes,
function
ma'am.
because first order derivative is increasing, and it is a concave function because second order derivative is negative. Concave means it is open towards the origin, or this is the origin. Listen, this portion is the origin portion. This is the opposite of the origin. Okay, that's the third
Yes,
case.
ma'am.
So I think accordingly you can find out the fourth case. So it is the homework up to you. So I'm leaving it. Just put this box in your mind. Okay, case 1. Same case as I did it earlier. I hope there is nothing wrong here. You can easily understand. Just, I think here is few examples. Given the function, it is a cubic function. Why? Because highest power is 3. That's why it is a cubic function. You see, first complete behavior analysis of the behavior. First, we'll say that it is a cubic function. Second, it is an increasing function or decreasing function. That depends on whether its first order derivative is positive or negative. So I find out the first order derivative. It is 3 into x minus 1 into x minus 3. Yeah. Which is your increasing function or decreasing function depends on the value of x. So how to know in that condition? First, we have to find out the critical point. What is a critical point? Either a maximum point or a minimum point is known as the critical point or an inflection point. How to know whether this is a maximum point or minimum point? For that, put the first order derivative equal to 0. The solution of x is known as critical point. Here, if I put the first order derivative, that is 3 into x minus 1 into x minus 3 equal to 0. So what will be the solution? 3 cannot be 0, clear? So either x minus 1 equal to 0, in that condition x equal to 1, or x minus 3 equal to 0, in that condition x equal to 3. So in these 2 points, either x is maximum or minimum, or maybe an inflation point. To check it whether maximum or minimum or inflation, we have to go to the second order derivative. Then we find out the second order derivative. Second order derivative means this is our first order derivative. Take its further derivative. It will be easy. I don't think you need to apply it to the product rule. Simply multiply the function, then use the either addition or the subtraction rule. So suppose accordingly we will get second order derivative will be 6 into x minus 2. Okay. If it will be positive, it's greater than 0, that means the value R2 is, the value of x for which the second order derivative is positive, we say that that is the minimum point. If the second order derivative is negative, for the values of x, the second order derivative is negative, I'll say that that is the minimum point. The values of x for which the second order derivative equal to 0, I say that is the inflation point. That is, the curve is changing its shape. Okay. It is the earlier one that we discussed. Okay. Here comes point of inflation. What is the inflation point? The point where the curve changes its shape. It just happens in case of our total cost curve or TP curve. As you know our diagram, just let me recall our diagram. I am drawing the total cost function here. Why it is not moving? Okay, no, here, sorry. This is my TC, so it should be Q and here should be cost. We are drawing the total cost curve. What is happening? The total cost curve, first it increases at a diminishing rate, that will increase at an increasing rate. Look at this point. What is happening? Before that, his shape will be called as concave shape. After that, his shape is convex shape. This point A. This point A. This is the point A. Okay. Before point A, that is from O to A. The shape, it is the curve with the, which shape is the curve? The curve with the, it is open towards the origin. That's why its shape is called as concave. After point A, afterwards A, it is convex shape. Convex shape. So at point A, I will say that the curve is changing its structure, changing its behavior. Before it is increasing throughout the output, I will say that my total cost is increasing. The first order derivative of TC will be positive. But from O to A, the second order derivative of TC, it will first it is concave shape. So what should be, it should be look like this, it should be greater than 0. After point A to onwards, second order derivative will be less than 0. That's why I'll say that it is a convex shape. So point A is the critical point where the structure of the curve is changing. That point is known as point of inflation. Let us look at the, if I draw the maxima minima diagram, there we'll find it clear all my drawing. Look. This is the diagram. Here, point A is the minimum point, right? Look at the minimum point. What is happening? It is a from the starting to suppose this is the name is A and this name is B. It is a moving. I have some problem. Up to point A to B, the shape of the curve is known as what? It is the convex shape. It is convex shape. Here, after B to onward, suppose B to C, what is the shape? It is the concave shape. The first convex, then concave. So the point will be a inflation point here. It will be the which point? Minimum point. But for if I look at for maximum point, how the curve will look like? This will look like this. This is the suppose this is the epicurve. This in this epicurve, this is the maximum point. At point A, the curve reaches its maximum. So from O to A, how it is the shape? The shape is open inwards. So it is called as concave shape. Do people understand me or not?
Yes, ma'am.
We are
It is
getting
clear
that.
about,
But
sorry,
Yes,
sir.
ma'am. Clear.
some second you have muted yourself, sir, I think.
Oh, am I audible now?
Yes, ma'am.
Okay. So where should I start? I think it is clear. Do you understand the definition of convexity, concavity?
Yes, ma'am. It is clear.
Imagine the table that first order derivative positive increasing curve, first order derivative negative decreasing curve, then come to second order derivative. If second order derivative is we call positive, that means the rate of change is at an increasing rate. So what should be the curve, convexity or concavity? If second order derivative is positive, it is convex or
Convex.
concave?
Convex.
All agree with this? Second order derivative is positive. Okay, clear. Then this is all up to you. You have the material, you can go to the slide and check it. But frequently look at the diagram, will be easily understand what is convexity, concavity, what should be sign. If the sign matters, that will decide whether this is a increasing, decreasing function, convex function, concave function. Look here. Concave. Concave means second order derivative is less than 0. Convex, second order derivative is positive. Okay. I think those you get your answer. Whether convexity requires a positive sign or negative sign. Here, this is the inflation point. Look at this. What type of curve it is look like? It is like our TC curve. First increases at a diminishing rate, then increases at an increasing rate. It is the TC curve, which is the inflation point. At this point, the structure of the curve is changing. Yeah. Look at the practical problem. Given f of x, you can calculate f dash x. It will be 3x square minus 6x. The first order derivative will be, I'm just writing the answer. I don't think I need to derive them. Okay, f dash x, first order derivative. This will be 3x square minus 6x. So what will be the second order derivative? It is take the derivative of this first order derivative. It will be 6x minus 6. A answer is ready. Then B, critical point. For critical point, put first order derivative equal to 0. This equal to 0. So what that implies, now take 3x as common, I will find x minus 2. That is equal to 0. So that implies either x equal to 0 or x is equal to 2. So the critical point are x equal to 2 or x equal to 0. Then classify it critical point as maxima or minima. Okay, for maxima, I'm writing here. Maxima. Put first order derivative equal to 0. And then find second order derivative should be less than 0. It is a maximum point. Plus minima. Minima. First order derivative equal to 0. Find out the value of x. Then find out the second order derivative. At that value of x, if second order derivative is greater than 0, that means x will be at minimum. So apply this rule. Here, second order derivative, that is f dash x. That is equal to 6x minus 6. So for x equal to 0, I will say this is 6 into 0 minus 6. That is equal to minus 6, which is less than 0. So x equal to 0 is my maximum point. Clear? So for x is equal to 2. What is happening to my second order derivative? This will be 6 into 2, then minus 6. That is equal to 12 minus 6 equal to 6, which is positive. That means at x equal to 2, the curve attains its minima. Clear? So diagram may look like this. I am saying may because we have to find out another point to be exactly sure about this curve. So he said that at x equal to 0, x equal to 0, it is the minimum point. Then this x equal to 0, x equal to 6. It is the maximum point. This may look like this, suppose. Maximum, therefore. Okay, maximum of this value occurs at x equal to 6. Minimum of this occurs at equal to 0. This curve cannot go below this. This will be wrong because the minimum point occur at x equal to 0. From onwards, it may increase. Clear? I think the diagram is clear. The diagram is not beautiful, but I hope you understand the critical points.
Madam, in the left side axis, what you said?
The left side of origin O, right?
Yes.
I say
Yes.
the curve will never go down after x equal to 0. Why? Because at x, the curve attains its minimum. That means
Yes.
the value of y when x is less than 0 should be more than this point. It should be like this. Or the curve may look like this. This or this. So this is the minimum point of the diagram throughout the range. This is the minimum point. So it should go upwards. It cannot go downwards. It is the maximum point. After this, it is falling. Clear? But to get the exact value, we have to find the value of x and y at critical points. We can draw the curve exactly. I'll leave it, that is not the question here. We have to find out the critical points. This is clear? Then come
Yes,
to
ma'am.
2. I hope so. Total cost is a cubic function. Find the marginal cost. How to find marginal cost? It should be the first order derivative of TC. Already remember, if the total function is given, take its first order derivative, it will give you marginal function. When total function is given, divide it by the what is called that independent variable, will get the average function. The clear indicate total function, first order derivative, marginal function. Total function divided by the variable, it give you the average function. The total, marginal, average, this three type of function is more than maximum time used in economics. So this, remember these 2 points. Okay. Find the marginal cost here. So what will be my marginal cost? That will be equal to 3q square minus 16q plus 20. The minimum of MC. So put MC first order derivative equal to 0. Here I find out my MC is equal to how much? Now 3q square, then minus 16q. Why not able to write clearly? I hope you understand my writings. Plus 20. This is my MC. For minimum, what I do? Put change in MC due to change in Q is equal to 0. So find out derivative of MC. It will be equal to 6Q minus 16. God. Minus 1, 616. That is equal to 0. That implies what is the value of Q here? It should be 16 divided by 6. Okay. The answer is ready. It said hint, inflation point of TC. What is the at inflation point? Second order derivative should equal to 0. Put second order derivative of equal to 0 means second order derivative of TC imply first order derivative of MC, which I put equal to 0. Okay. Now, elasticity. Elasticity, the very definition of elasticity says to what extent if the independent variable change by 1%, to what percentage my dependent variable will change. In general notation of function, we say that y is a function of x. We say y is a function of x. So x is my independent variable, y is my dependent variable. So elasticity says if x changes by 1%, then to what percentage y will change. That is called an elasticity. The symbol of elasticity, this n, this symbol is read as nu. This is a symbol of nu. N-E-W, nu. Nu, what will be the percentage elasticity formula? It is percentage change in y divided by percentage change in x. How to calculate percentage change in y? It should be change in y divided by y multiplied with 100. Here, it should be multiplied with 100 should be mentioned here. It doesn't matter because in the numerator multiplied with 100, in the denominator multiplied with 100. The 100 will be cancelled out. They do not make any changes if I multiply or not multiply. By make a little bit rearrangement, we'll find out the elasticity formula of elasticity equal to x by y into dy upon dx. Sometimes this is read in this way. Make a look at this. This is what? It is the marginal function, right? Marginal function because first order derivative. This is the marginal function. And this is the reciprocal of average function. How to get average function? Given the function, here the function y divided by how much dependent variable is used. This is studied as average function. So what is elasticity? Mu equal to, you can say marginal function m of f divided by average function. Yeah. Remember like this or remember by this formula. This is called the elasticity. It is clear that in calculating elasticity will not get in unit because numerator unit in the numerator and unit in the denominator. Both will be cancelled out. So ultimately, the ratio will be free from any unit.
Ma'am, somewhere we are using the minus sign to find out the elasticity.
Elasticity. When you say, for example, elasticity of demand, price elasticity of demand, which is symbolically write as EP. Actually, the price elasticity of demand EP is known as not only EP, it is the mod value of EP. The mod value, because we know if it's a demand curve, by default it will be a negative sign, because dy by dx will give a negative number. So the sign will be negative. So to understand elasticity, we say it is either how we study elasticity. The values of elasticity is ranges from 0 to infinity, right? So we are not considering the negative part, without ignoring the negative part, only look at this value. Clear? That's why ignore the sign while calculating elasticity. The sign
Okay.
just will say that whether the relationship between two variables is positive or negative. The sign will just give you the information about this. But elasticity said to what extent it will change. It will increase or decrease, the sign indicate. But we are not dealing with increasing or decreasing. We are not dealing with to what extent my variable will respond to change in x. That's why we are ignoring the sign. There will be no problem if we ignore the sign. You will get the same result, same interpretation. Okay. Then come. Difference between elasticity and slope. So what is the slope is absolute change, whereas measure is relative measure. Because if elasticity changes, look at the calculation of slope and the calculation of elasticity. Slope says dy upon dx. But elasticity says dy upon dx multiplied with x by y. So ratio of x by y related to this, what is the value of the change? Therefore, it is a relative figure. That's why it is studied as percentage change in, is a percentage change in y due to 1% change in x. But what is slope studies? It is a change in y for unit change. For 1 unit of change, how y is changing. But elasticity is not saying whether x is changed by 1 unit. It simply say if x is changed by 1%, then how y will respond. Okay. I think not that much. Let's go to another. Yes, types of elasticity. We said look at the value of elasticity. Okay, first case. We have 5 types of elasticity. First type we say, what is this is the case where elasticity in this condition, elasticity equal to 0. EP. Elasticity means this is studied as elasticity, the mod value of EP. It equal to 0. That means quantity change in quantity demand is not at all responding to price. You may change the price, quantity demand is fixed, it is not changing. Right? So EP equal to 0. It's a first case. Because this is called as perfectly inelastic. Perfectly inelastic. Elastic. That is the your case. Oh, it is mentioned here. Look at this. Elasticity is greater than 1. We call it, it's a elastic demand. Greater than 1 means percentage change in y is greater than percentage change in 1. The percentage change in x. So what should the diagram look like? In the case 1, in this condition, the diagram will be a greater than 1. So let's take the example that it is a demand curve. So it will be demand curve. It will be more flat. Again, inelastic demand. That means elasticity is less than 1. So it will be steep, not flat. This is steep. Okay. Then equal to 1. This is 50% steepness and 50% flatness. In between like this. Elasticity equal to infinity. So flat. Perfectly flat means it is a horizontal line. Then elasticity equal to 0. That means it is perfectly steep. That means a vertical line. It's better. There's another way. If I look into the diagram together, see how it is changing. First, elasticity is infinity. This is flatness is peak, at its peak. Then elasticity suppose is greater than 1. Demand curve will be like this. Then elasticity equal to 1. This is the again demand curve. Elasticity is less than 1. This is the demand curve. Again, more steep. Elasticity equal to 0. It is a straight vertical line. Okay. Then when move its elasticity value from infinity to 0, so what is happening to the demand curve? Is flatness is decreasing and steepness is increasing. Flatness means high level of flatness is it is a horizontal line. High level of steepness means it is a vertical line. When you reduce elasticity value, the demand curve starting from a flat line, horizontal line, to it become a vertical line. Is it clear? I am just moving forward because there are
Yes,
so many
ma'am.
slides.
Yes, ma'am.
Okay. The formula price elasticity of demand. It is the percentage method because we have studied three methods. In percentage method, the example is percentage change in quantity demand divided by percentage change in price. Let me delete all. Okay. So this is the formula dP upon dQ into QD by P. Sign, if it's a normal good, this sign will be negative. So for calculation of elasticity, we take its mod value, mod of ED. If it's a given good, the sign will be positive. Why? Because price and quantity move in the same direction. When you say the elasticity equal to 2, that means it is greater than 1. That means it is a elastic demand. That means if price is increased by 1%, the demand will fall by 2%. If price elasticity equal to 0.5, that means it is inelastic demand. That means if price is increased by 1%, the demand will increase only by 0.5 percentage. Okay. Okay. Given the interpretation, next slide. Linear demand curve. Given the demand curve, you have to calculate the elasticity. It is easy. Put the formula, find the first order derivative, then find out the value P by quantity, multiply both. Here the result is minus 2 by 3. For elasticity interpretation, ignore the sign because the sign, negative sign indicates it is a normal good. It means if price will increase, quantity demand will fall. This is the interpretation of negative sign. Now look at the absolute value. That is 2 by 3. That is less than 1. So less than 1 indicates it is an inelastic demand. That means if with the price is increased by 1%, the how many percentage demand will fall? It will fall by 0.66 because 2 by 3 equal to 0.66. If 1% increases, then demand will fall by 0.66. Yeah, this is the interpretation. Then go to next. Here, same. You can easily find out elasticity. So I'm just skipping it. It is the point method of calculating elasticity. So given your demand curve, at the center of the demand curve, elasticity equal to 1. When you go downwards of the demand curve, elasticity goes on decreasing. That is the inelastic zone. Below the midpoint of the demand curve, the demand is inelastic. Above the midpoint of the demand curve, the elasticity is elastic. That means greater than 1. Okay, there is little bit changes. Oh my God, what is that? Oh, I have done something. Oh my God, I had the diagram. Okay, here. I think something, it is by mistake, it's something wrong is here. Let me indicate it here. If the sign should be reversed, your price fall, if the elastic region, when price falls, its total revenue should increase. And here, if price falls in the inelastic region, total revenue will fall. Why I'm saying? Go and check your plot to book. That is a method called an expenditure method. Once expenditure, suppose consumer expenditure is the producer's revenue. It's the same thing. If it's elastic demand curve, when price falls, its total expenditure or total revenue should increase. If it is inelastic demand, as price falls, its total expenditure, which is same as total revenue, should be decreasing. Why? You can go and analyze the expenditure method. There will get the answer. Why it is wrong. Okay, it is given your elasticity and how the graph will look like. Infinity, horizontal line. This is infinity, so graph will be horizontal line. Elasticity equal to 0, graph will be vertical line. Elasticity equal to 1, so 50% steep, 50% flat. Less than 1, more steep. Greater than 1, more flat. Okay. Then next. Income elasticity. Just replace in place of price, income. What is the income elasticity of demand measures? It measures if income increases by 1%, to what percentage my demand will either increase or decrease. That is called as income elasticity of demand. It is represented by E of Y. E subscript Y. The formula is Y by Q into dQ upon dy. We said elasticity value can be equal to 0, or it can be less than 0 or greater than 1. If greater than 1, luxury good. And less than 0, that is negative, inferior good. In between 0 to 1, it is normal good or necessary good. The another type of elasticity, we say cross price elasticity. It means one's demand due to change in others or relative goods price. And the sign is clear, substitute good. That means both goods are joined either T or copied. Clear? The elasticity will be positive. Why? If suppose T price has increased, the T become costlier, the demand for copy will increase. T price increase, demand for copy increase. Same direction, the elasticity positive. Complementary goods is a negative. Example, suppose price of petrol increase, the demand for petrol will fall, the demand for car will also fall. As the demand for petrol increases, the price of petrol increases, demand for car falls, opposite direction. The sign should be negative. If elasticity equal to 0. Or whatever may be the suppose change in the price of, suppose like the example of two independent goods. One is pen, another is cycle. So if price of the pen changes, either increases or decreases, there will be no change in the demand for cycle. The change equal to 0. Therefore, it is an independent good. Okay. Go to next slide. You have to calculate elasticity. I'm skipping this part so you can calculate the first order derivative and nothing else. Optimization. This is the important point. Maximum we use this value, maximum value, minimum value. Remember the condition for optimization. For maximum, find out the first order derivative, put it equal to 0. It will be in the below diagram. Then this is the condition. Okay. This is the condition for maxima. Put first order derivative equal to 0. Solve the equation. Find the value of x. Then go to second phase. Calculate the second order derivative. If for the value of x, that we find out after setting first order derivative equal to 0. For that value of x, if second order derivative is negative, it is maximum point. If second order derivative is positive, minimum point. Equal to 0, inflation point. Just remember, for maximum, minimum, or inflation, always put first order derivative equal to 0. Now, second order derivative. Positive, it is positive, that means minimum point. It is negative, that means maximum point. Equal to 0 is inflation point. Why? And just look at this diagram. Might not moving here. Okay. As I remember, it is the maximum point. It is the maximum point in this diagram. So its second order derivative should be negative. This is the minimum point. Second order derivative should be positive. Same your diagram is mentioned. Just picture the diagram. If the maximum, it should be a inverted U shape. The maximum means less than 0. Minimum means greater than 0. The minimum point means it is a U shape. U shape means it is second order derivative is positive. We have to remember this box. Okay. Steps. Just go through the slide and just remember the steps. Then we'll calculate. They do some calculation. We can easily understand in this condition. Find the optima, maxima, minima. How to do it? Given the function, find its first order derivative, that is equal to minus 2x plus 4. Put is equal to 0. The value of x equal to 2. So we say that x equal to 2 is the critical point. That means the curve at this point x equal to 2 may attain a maximum value or may attain a minimum value, may be inflection point. How do I know which point it is? Maximum, minimum, or inflection? Go to the second order derivative. At x equal to 2, calculate the second order derivative. Okay, second order derivative. This is equal to minus 2. Look at this. Whatever may be the value of x, second order derivative is always negative. Second order derivative negative indicates what? It should be a maximum. So the curve attains its maximum where at its critical value. And what is the critical value? The critical value is here that we get after putting first order derivative equal to 0. This x equal to. But to know what is the value of the critical value, look at the first order derivative. To determine whether the critical value is maximum or minimum or inflation, go to second order derivative. Accordingly, you will interpret. Okay. So I am leaving this example up to you. So put first order derivative, that is 2x minus 6 equal to 0. Find out the value of x. Now calculate the second order derivative. Then that second order derivative, put the value of x, that is the critical value. At critical value, if the second order derivative is positive, we say it is a minimum point. If second order derivative is negative, it is a maximum point. If the second order derivative is equal to 0, it is a inflation point. Again, there's an example, so I'm skipping it. Okay, this is a best example because it's using economic terminology. Given total cost function and given the then price, value of price. Output label that maximizes profit. Okay. What is the profit? Definition is total revenue minus total cost. If I assume that it is a competitive market, so total revenue is equal to price into quantity. Value of price is given 60. How to get the value of Q? So we have to find out Q. It is not given. So P into Q minus given the TC, differentiate it. This is minus 2Q square plus 40Q minus 100. We have to maximize this profit. At what value of Q, the profit pi is maximum. Or in other words, for what value of Q, the profit is maximum. That means put the first order derivative of profit with respect to Q and set it equal to 0. The first order derivative will be minus 4x plus 40. It is the first order derivative. Put equal to 0. Solve it is Q equal to 10. So 10 is the critical point. So whether at 10, Q equal to 10, the profit may be maximized, may be minimized, or inflation point. How to know whether maximum or minimum? So calculate the second order derivative. The second order derivative equal to 4. That means it is negative. It's negative means this is the optimum value. As Q equal, don't think at Q equal to minus 4, wrong. At Q equal to 10. At Q equal to 10, this value of Q, the function attains its maxima. So what is the value of maximum profit? Go to the profit function, put the value of Q equal to 10, the answer is 100. Okay. Now, again another example. This is the example, so I am leaving it. Because we have to go, we have to finish the slide. Now, homogeneous function. What is a homogeneous function? Simply say, suppose you have a function that's y equal to f of x and y. Okay. Now, you do one thing. If all the independent variables are increased by a given factors, let us say t. Now, in place of x, I write tx. In place of y, I will write ty. Here, the independent variable before it was x, it is increased by t times. So it becomes t of x. Here it becomes t of x. Yeah. The y variable, at the original it is y increased by t times. So I put in place of y, it is t of y. So what will be my output? If my output can be represented that the t factor, the factor by which the independent variable is multiplied, the factor can be taken out of the function. So look at this is the f of xy. I can take this t value out of the function. That's why I say it is a homogeneous function. For example, if I increase labor by 2 times and capital by 2 times, either my output will be increased by 2 times or more than 2 times or less than 2 times. If I can justify this, then I will say that it is a homogeneous function. Then comes, what is the degree of homogeneity? When you factor out the factor t, what is the power of that t? That power will say the degree of the homogeneous function. If the power is equal to 1, its homogeneous degree is equal to 1. If power is 2, it is a homogeneity of degree 2. If power is 0.5, it is a homogeneous function of degree 0.5. For example, look at this diagram here. This example here, f of x equal to x square plus x plus y. Now, if f of x equal to this, then what is the value of f of tx and ty? Simply, in the initial function, put at place of x, put tx square. At place of y, put ty. Then find out. Then you say that is equal to same as t square into f of xy. That means the t here, this t, which is inside the function. Here I take it, the t taken outside the function value. It is a homogeneous function. So the power of t equal to 2, so it is a homogeneous of degree 2. Yeah. Okay. The steps to check whether it is homogeneous or not. Let's go and do some example here.
Ma'am, can you
Yes,
explain again about the what the meaning of homogeneity basically? If a function is homogeneity at degree 2, then what it denotes basically, ma'am?
it denotes that if suppose take an example of for demand product output function, total product function. It says degree the total production function is a homogeneous of degree 2. It implies if both labor and capital are increased by t times. T times. Then the output will increase by t the square times. Here I am doing it. Let me give you an example. This is okay. Suppose given my TP. Yeah. TP is equal to, suppose I will write A, suppose this is labor to the power 0, suppose 1 and capital to the power 1. It will be homogeneous of degree 2. It imply let my, suppose labor increases by suppose 5 times and capital also increases by 5 times. Though my output will increases by 5 square times. Okay, if it's homogeneous of degree 1, it will be if labor is increased by 5 times, capital is also increased by same that 5 times, then output will increase by 5 to the power 1 time. That is equal to 5 times. Okay, is it okay?
Yes, ma'am,
Ajay
it
sir?
is clear. Yes, ma'am, yes.
Okay. Then here I'm just do one example here. We have to homogeneous. Find out it is homogeneous or not. If homogeneous, what is the degree? How to do? In place of x, you can write lambda x or tx. Both will give me same result. So given the function 6 x square y minus y cube. So the new function will be f of, suppose lambda times lambda x and lambda y. That is equal to 6 into lambda x. In place of x, I will write lambda x square. Into in terms of y, in place of y, I will write lambda y. This minus y cube. Y the lambda y is q. So that is equal to 6 lambda square x cube into, sorry, x square. This is x square. This is into lambda into y minus lambda cube y cube. So that is equal to 6. Lambda, this lambda square and lambda, it become lambda cube into x square into y minus this is lambda q into y cube. So I can take lambda q as common outside. So in the bracket it will be 6x square into y minus y cube. So what is this? This is nothing. It is the f of y. What is the value of this f, lambda x lambda y? This value is that the same f of y but multiplied by lambda to the power q. So where I put the lambda is inside the function. Here my lambda is outside the function. I can factor out the lambda from the function. So it will be a homogeneous function. Now what is the degree? What is the power of this lambda? Is 3. So degree equal to 3. It says if both, suppose x and y are increased by 2 times, then my result, that f of x, y, let it be z. Z will be increased by, suppose 2 times it has increased, the z will be increased by 2 to the power 3 times. S increases by 2 times, it is 2x. Y increases by 2 times, it is 2y. So my z, that is a function of f of x, y, will increase by 2 to the power. What is the degree here? Q. That is, it will increase by 8 times. Clear? So if it's the production function, so it definitely will indicate what? It is the What times? You can say it is a increasing return to scale. The rate at which the input has increased, output increases more than that rate. That is more than 2 times. 8 is more than 2. Okay, increasing returns. Okay. Okay. Okay, listen, I cannot go in details because I fear I'll be again running out of the time. I'll not able to complete this. This is not a deep analysis. This is an overall analysis, so that you are able to recall this analysis, recall the mathematics, so we can go and apply it in microeconomics. That's regarding those students who have not yet studied this part of the mathematics. Don't worry, in your classes, PG classes, you will understand this. And other PG second year student, you also recall it. Okay, given. Degree is 3. Yeah. If input are doubled, then output will be 8 times. Yeah. Yeah. It's a Cobb-Douglas production function. A, k to the power alpha, L to the power beta. Increase k by lambda time and labor also by lambda time. So what a percentage my output increase by? It is in that lambda is factor out. So it is clear it is a homogeneous function. What is the degree? Degree equal to what is the power of lambda? That is alpha plus beta. The degree of the function is alpha plus beta. If alpha plus beta equal to 1, which is a constant return to scale, it means if both labor and capital are doubled, output will also be doubled. It's a constant return to scale. Now, if alpha plus beta greater than 1, it means if both labor and capital increase by a given amount, so for 2 times, then output will increase by more than 2 times. If alpha plus beta is less than 1, we say diminishing return to scale. That is, if labor and capital are doubled, the output will be less than doubled. You just have to remember this. Okay. Okay. Now, Euler theorem is otherwise known as production exhaustion theorem. This is if you say that f of xy is a production function. So, first order derivative of f with respect to x will give you the marginal product. Similarly, derivative of f with respect to y will give you the marginal product. So basically, just remember the statement. What is Euler theorem explaining? It said that if the factors are paid according to their productivity, total output will be adjusted. That's why this theorem is otherwise known as product exhaustion theorem. It's written here. In the production function, it is written as what is k? The capital. Here, let x equal to k and y equal to L. So they replace its value k into marginal product of k. Suppose 1 unit of capital will give you its value equal to MPK. I have used k amount of capital. So how much I am paying? Na k into MPK. Similarly, suppose 1 unit of labor is paid by the amount MPL. I am using L amount of labor. The total payment to labor will be L into MPL. Now adding these two will give you the value of Q. Q is the output. If it is called constant return. Remember here, the homogeneous of degree k, it mainly justified for what is called a constant return to scale. If each factor is paid according to marginal product, then total output will be adjusted. No profit will be there. This is given the function. It will be a homogeneous function. It will degree will be 3. You can check it. Partial derivative. Partial means when I say use the word partial, that means keeping some factors are constant. Like you are doing partial equilibrium analysis, keeping some factors constant. What is the effect of others? Just like studying the price elasticity of demand, it is a partial analysis. Why? I'm studying the change in price or the effect of change in price on demand, keeping income, taste preference constant. Partial means some variable is kept constant. That's called partial derivative. It is denoted by delta. This symbol is the delta, not d. So when a function is there is more than one independent variable, there we will use partial derivative. If there is only one independent variable, we will use plain derivative. That is derivative of f dy f of dx. In place of partial, it is delta f upon delta x. Okay. Given the function, then find out its Euler expression. I think I do not need to explain it. You can easily check it. Go to other point. Okay. It is,
Yes.
it is out. Okay. See, product exhaustion holds or not. Given our information is demand, sorry, production will be a steady production function, and also the value of alpha plus beta equal to 1. If if you find test, it will find that it is a homogeneous function and its degree equal to alpha plus beta is equal to 1. Alpha plus beta is the degree. Here it assumes that the degree equal to 1. That means it is a constant return to scale. So find out marginal product of capital, then find out marginal product of labor, then use this formula K into marginal product of capital plus L into marginal product of labor. Then this answer will be that is equal to Q. Okay. Capital is paid according to marginal product. Labor is also paid according to its marginal product. Total payment equal to output. That means after paying this, my output is exhausted. No more output is left out. That's why we say it is a product exhaustion theorem. Yeah. Now, theorem marginal product. He said if a function is homogeneous of degree k, then its marginal function will be also homogeneous but degree less by 1. If a function is homogeneous of degree 3, then its marginal, all the marginal function will be homogeneous function, but degree will be 3 minus 1 equal to 2. Okay. If suppose in this condition alpha plus beta equal to 1 means constant return to scale. It is a constant return to scale. That means it's a homogeneous function. Degree 1, this marginal function will definitely be a homogeneous function, but degree equal to 0. That means when you factor out the t value or the lambda value from the marginal function, it should be lambda to the power 0. That's right. Okay. Clear. Homothetic. What is a homothetic function? Just remember, given your homogeneous function takes its monotonic transformation, the new function will be a homothetic function. So what is a homothetic function? It is expressed as a monotonic transformation of a homogeneous function. I hope everybody know what is a monotonic transformation. In the Euclid analysis, you have studied this. So I don't think I need to explain it. So, what the relationship between homogeneous and homothetic? All the homogeneous function are homothetic function, but not necessarily the reverse is true. Just like we say that all the given goods are inferior goods, but the reverse not necessarily true. This is the relation. Look in the example, u equal to x to the power 0.5, y equal to 0.5. It is homothetic, but can you say it is a homogeneous or not? U function given u, x to the power 0.5, y to the power 0.5. So I can factor it out. It will be homogeneous of degree 1. Now take its log value. The log always gives you a monotonic transformation. The log value of the new function will be a homothetic function. But is this homothetic function is a homogeneous function? Not. You cannot factor out. Suppose you in place of x you take lambda x, in place of y you take lambda y. So answer will be 0.5 into ln lambda x plus 0.5 into ln lambda y. Now lambda cannot be taken outside the function. So it cannot be a homogeneous function. So all the homogeneous function will be a homothetic function, but reverse will not true. Okay, this is the per test. Just do, you can do the exercises, no need. Okay, I'll just do that exercise. We will have some economic applications. That means economic terms are used. Like this is the total cost function. Given the total cost function and the market demand function of a competitive firm. Clear? It is the, see the total cost function, this x is a function of P is my demand function. So the answer, the level of output at which profit will be maximized. For maximization of profit, to find out profit, let me do it here.
Ma'am,
Yeah.
this is the inverse demand function. No.
Right. Listen. Generally, we say that demand function is quantity demand depends on price. By that logic, it is a x is the quantity demand, which is a function of price. We should say it is a demand function. The reverse inverse demand function will be P as a function of X.
Yes.
That will be
Yes.
the inverse demand function.
Yes,
Because the
ma'am.
by definition of demand, what the demand indicate? The quantity demand depends on price. The price should be independent variable. X is the dependent variable. The quantity demand is the dependent variable. Quantity demand depends on P. That's with the demand function, like X is the quantity demand, P is the price. It is clear that X depends on P. It is the demand function. What is the inverse demand function? P become a dependent variable, quantity become a independent variable, P as a function of X. That should be called as inverse demand function. Okay,
Yes,
Sangeeta
ma'am.
madam?
Sorry. Yes, ma'am.
Okay. Now I have to calculate profit. How to calculate profit? We know profit is indicated by the term pi. That is equal to total revenue minus total cost. So how to calculate total revenue? It is given that it is a competitive firm. So total revenue equal to price into quantity. Quantity is X here minus total cost. It is equal to 1 by 3 XQ minus 10 X square plus 9X plus 1000. Okay. Given the value of how to find out this P and X. See, it's better to represent, to convert all the variable in terms of X only. The profit should be dependent on X. So it will be easy to calculate. For that, we have to omit the value of P. We have to write P in terms of X. So how to get the value of P from here? We can say that is equal to, that imply 9X is equal to 12 minus P. So what should be the value of P? P equal to 12 minus 9x. Clear? Simply write in terms of P. You write is 12 minus, it should be 9x. For me, handwriting is understood. It is out of my control now. Minus 1 by 3 x cube minus minus plus 10x square minus 9 minus 9x then minus 1000. Okay. So just solve it. It will be minus 1 by 3 x cube. So I'm arranging it on the order of its power. Plus 10 x square. Here minus 9x, another 9x. So it becomes minus 18x. 18x. It is minus 1000 plus 12. It becomes minus 9900. It should be, I think, 88. Right. Profit maximization, take the first order derivative, that is indicated by pi dash. Pi dash, it should be minus 1 by 3 into 3 x square plus 10 into 2, that is 20x minus 18. That is equal to minus x square plus 20x minus 18. For
मैडम
maximize, yes sir?
मैडम जो एक्स टा थिला कोडे गला 9 पी एक्स बरा पी टा 12 माइनस
P,
9 एक्स
oh, right. Yes, right, sir, right, sir.
ओके
I have omitted the x here. It is the price is 12 minus 9x, so x should be here.
ओके
Okay, thank you, sir. Thank you, sir.
ओके
So it should be 12x. So I have to make little bit changes. I will done a mistake. It should be like this. Okay, okay. Okay, thank you, sir, for correcting me, rectifying me. Okay, okay. It is a tedious work for me. Okay, okay, okay. What should be this value? Okay. This will be, that is equal to 12x minus 9x square minus 1 by 3 x cube plus 10x square minus 9x minus 1000. So I have to arrange it. It is minus 1 by 3 x cube. Please check it if something is omitted or if I am doing something mistake. Please rectify me. Now it is minus x square. It is minus 9x square. It is plus 10x square. So value will be plus x square only. Plus x square. Square term is over. Now look at x term. It is plus 12x. It is minus 9x. So what will be the result? Ultimate result will be plus 3x. Now will be minus constant term, that is the 1000. So for profit maximization, what is pi dash? What is the pi dash? Find out pi dash. It should be minus 1 by 3 into 3. That is equal to minus 1. Minus 1 into x square. or simply you can write minus x square plus derivative of x square becomes 2x. 2x plus derivative of 3x equal be plus 3. That equal to 0. Hopefully there is okay. Now you have to find, put it as 0. This is the minus x square. Let me do it properly. Minus x square plus 2x plus 3. Oof, God, plus 3 equal to 0. It is a quadratic equation. Either you factorize it or you do that is the Sridhar Acharya where x equal to minus b plus minus root over b square minus 4ac equal to 0. But just factorize it. So we have to divide 2x in such a way that its addition will be 2, but multiplication will be minus 3. Can I get something? If I say in place of plus 2x, I will write plus 3x minus x. It become plus 2x and plus 3 minus become minus 3. So the answer will be, okay, after that put that is equal to, that imply it is minus x square is here. In place of plus 2x, I am writing plus 3x minus x. And this is plus, that is 3. This value, let me omit it. Okay. Oh, it is not moving. Okay. So do it, and this is plus 3 is equal to 0. That is equal to 0. Now, that implies from this first two term, takes x as common, it will be minus x and plus 3. Then from second two term, say what to common should be take minus 1 should be taken out. Take plus 1 should be common, it will be easy. It becomes minus x and plus 3. That is equal to 0. So either I will say that is equal to minus x plus 3 multiplied with x plus 1. X plus 1 is equal to 0. So either minus x plus 3 equal to 0. In that condition, x will be 3 or x plus 1 equal to 0. In that condition, x equal to minus 1. The critical value will be x equal to 3 and x equal to minus 1. That what value of x? I said my second order property is maximum. That means find out the second order derivative. The second order derivative here phi double dash will be minus 2x plus 2. Here at x equal to minus 1, you can find the second order derivative equal to plus minus 2 minus 1. That means plus 2 will be 4. Is it positive? I can say that the first order this at x equal to minus 1, the profit cannot be maximized as it becomes positive. Now put x equal to 3. At x equal to 3, my second order derivative, that is minus 2 into 3. It is minus 6 plus 2 equal to minus 4. Here at x equal to 3, my second order derivative is positive. So I say that at x equal to 3, the profit is maximized. Answer is C. Okay, I have done the calculation here. I hope you understand the calculation. Accordingly, you can solve any such type of problem. They're not a big issue to find out the optimum function. Just remember, find out the derivative.
मैडम सीटा टी राउंड कर दियंतु सीटा
Okay. Okay. How to say? Clear? This is the answer.
ओके
Okay.
देखंतु मैडम कोन केंति सॉल्यूशन टा भी देथियो बोले ना पर
Okay, maybe. Let me go down. Okay, your answer is C. X equal to 3. X equal to minus 1 rejected. Because second order derivative becomes negative. Okay. Now, okay, UGC NET PYQ production function. Given the production function, find the labor units required for maximum output. That means the first question is asking at what value of labor, that is L, my product output is maximized. That means this is the TP function, Q equal to 40L plus 3L square minus LQ by 3. Put its first order derivative equal to 0. Solve the value of L. Then go to the second order derivative. Find the second order derivative. For that value of L, if the second order derivative is, we say, what is that? Negative. So we can say at the value of L, given value of L, the total product is maximized. I think you can do the calculation. I am leaving it up to you. The answer might be there. This is the same process you have to follow. Then find the maximum value of marginal product of labor. So here you have, your function is not Q, it is the marginal product.
मैडम
Just find out the marginal product. Yes,
भक्ति
sir.
मैडम
Yes,
सॉल्यूशन
sir.
नहीं आपण चलना सॉल्यूशन उठे जल्दी हो देखुना सॉल्यूशन टा हाँ
Okay, yeah. Given the product function, first order derivative, I set it equal to 0. Solve the value of L equal to 10 and minus 4. Calculate the second order derivative, its value equal to 6 minus 12. That x equal to, put L equal to 10. What is the value? Value will be negative. It is clear. At L equal to 10, the total product is maximum. So I am rejecting the value of L equal to minus 4. It is clear. Go to next term, marginal product of labor. Find out the marginal product. It is the first order derivative of total product. Okay, give what was the my? This is the total product curve. Its first order derivative will be L square minus 6L minus 40. So this is my marginal product of labor. Given the marginal product of labor here, let's maximize it. So put the first order derivative of this MPL, that is equal to this 6 minus 12, that is equal to 0. Solve for it, we'll get L equal to 3. That L equal to 3, we have to find out whether the function is maximum or minimum. Again, second order derivative of marginal product of labor, which is minus 2, by default it is a negative. So I can say at L equal to 3, my marginal product of labor is maximum. Clear? Where AP equal to MP. Okay, you can find out the value of L, but remember one thing, with the total product for where AP equal to MP, where both are equal at the maximum point of AP. So we just simply have to point out or find out the product, the labor, the amount of labor where AP is maximum. Just do that. We don't need to solve in this way also. Easily apply your the economic understanding. So given your total product function, you can find your average product function. Put its partial derivative equal to 0. For that value of L, AP equal to MP. Easily you can do it like this also. Okay, that two different method, but both will give you the same result. Okay, get question. Given f of xy, be a continuous differentiable homogeneous function of degree 4, which of the following is necessarily true. This A cannot happen because this will happen. It's the product exhaustion theorem. Here, this happen if it is the homogeneous of degree equal to 1. So that we cannot say. So, what you can say, if degree equal to 4, this option C will be the answer. If we factors are paired according to their marginal product, then total output will be exhausted. It is clear. I am also with doubt. 1 is not the answer, it is confirmed. But what should be the value of B, C, D? Let me check it. Given the direct application, the homogeneous function of degree K. Okay, it is a degree of 4. That's why C is the answer. Okay. I just have to remember this. Production exhaustion theorem. What is that? Is factor are paired according to their marginal productivity. Total output will be exhausted. If labor capital both are increases by a given amount, the output should be increased by you can say t to the power 4 times. So output should here in the right side of this equation should be 4 times of the original output. That's why C is the answer. I have to check it again. This application is a difficult question. How to justify it? I think I need more time to analyze it. I'm skipping it for today. Okay. Is this a next question? TC given the TC, given the value of P, profit maximization output. It is we have done this type of formula.
भक्ति
Yes,
मैम
sir. Yes, sir.
ମୁଁ ଆହୁରି କ୍ୱେଶ୍ଚେନ୍ ଆଜି ପଠେଇଦେବି ଆସାଇନମେଣ୍ଟରେ
Okay.
ଅପଲୋଡ୍ କରିଦେବି
Okay, okay.
ତ ସେମାନେ ଏଗୁଡ଼ା ସବୁ ପ୍ରାକ୍ଟିସ୍ କରିକିନା କାଲିକି ମାନେ ରେଡି କରିକି ସବମିଟ୍ କରିବେ ସେମାନେ
ହଁ ସେଇଟା
ଏଇଥିରେ
ସବୁ ଖାଲି ଆପ୍ଲିକେସନ ଗୁଡାକ ହିଁ ଅଛି ଆଉ କିଛି ନାହିଁ।
ହଁ ଏଗୁଡ଼ା ବି ଯୋଉ ଆପ୍ଲିକେସନ ଅଛି ସମସ୍ତେ ଯେମିତି ଆସାଇନମେଣ୍ଟରେ ସେଟା ସବମିଟ୍ କରିବେ ଆଉ କିଛି ନାହିଁ
Okay. Okay.
ଆଉ
So this is the overall
ଆଉ
idea about the mass.
ହଁ ଆଉ ପୁରୁଣା କ୍ୱେଶ୍ଚେନ୍ ମଧୁସ୍ମିତା କହିଥିଲା କିଛି କଲେକ୍ଟ କରିଥିବ ବୋଲି ମୁଁ ଜାଣିନି
ସାର୍
କେତେ କଣ।
ସାର୍ ମୁଁ ଆଜି ଆପଣଙ୍କୁ ପଠେଇଦେବି ଆଉ
ହଁ
ଆଉ କିଛି ପାର୍ଟ ଅଛି କରିକି ମୁଁ ସେଣ୍ଡ କରିଦେବି
ହଁ
ଆପଣଙ୍କୁ।
ତ ମ୍ୟାଡାମ ଆପଣ ମଧୁସ୍ମିତା ପଠେଇଲେ ପୁରୁଣାଟା
ହୁଁ।
ଏଇ ସେକ୍ସନରୁ ନା
ହଁ
ମଧୁସ୍ମିତା?
ହଁ
ସାର୍ ମୁଁ ଓଭରଅଲି କଲେକ୍ଟ କରିଦେଇଛି ଯଦି ଆପଣ
ହଁ
କହିବେ
ଠିକ
ମାନେ
ଅଛି,
ମୁଁ
ଯୋଉ ସେକ୍ସନ ଗୁଡ଼ା ମ୍ୟାଡାମ ଆପଣ ପଢେଇଥିବେ ସେଇ ସେକ୍ସନ ଗୁଡ଼ା କେବଳ ସଲ୍ୟୁସନ କରିଦେବେ ଆଉ କାଲି ଡିସ୍କସନ ହବ, କିନ୍ତୁ ଏମାନେ ସମସ୍ତେ ପ୍ରାକ୍ଟିସ କରିବେ। ମୁଁ ଆସାଇନମେଣ୍ଟ ଅପଲୋଡ କରିଦେବି ମ୍ୟାଡାମ ଆଜି।
ଓକେ ସାର୍ ଅପଲୋଡ କରିଦିଅନ୍ତୁ, ଯଦି ହବ ତାର ମୁଁ ଆନ୍ସର ବାହାର କରିକି ସେ ଆନ୍ସରଟା ବି ଅପଲୋଡ କରିଦଉଛି। କାରଣ ସେ ଆନ୍ସର ଗୁଡାକ ଏଠି କାଲକୁଲେଟ କରିବା, ବାହାର କରିବା, ଲେଖିବା ଗୁଡାକ ବହୁତ ଟିଡିୟସ୍ ପ୍ରୋସେସ ହେଇଯିବ।
ହଉ ଠିକ ଅଛି, ନାଇଁ
ବେଟର
ସେଟା ତ ଆମେ
ଖାତା ପେନରେ ମୁଁ କରିକି
ପ୍ରିଭିୟସ ଇୟର
ଅପଲୋଡ କରିଦେବି।
କ୍ୱେଶ୍ଚନ ଟା କରିବା ମ୍ୟାଡାମ। ସେମିତି
ୟେସ୍
ପ୍ରିଭିୟସ
ସାର୍
ଇୟର
ୟେସ୍ ସାର୍।
କ୍ୱେଶ୍ଚନ ଟା ଆପଣ
ଓକେ ସାର୍
ସେମିତି ଆମେ କେମିତି ସଲ୍ୟୁସନ ହବ ସେଟା କରିବା ପ୍ରିଭିୟସ ଇୟର କ୍ୱେଶ୍ଚନ ଟା।
ଓକେ ସାର୍।
ଓକେ ଓକେ ମ୍ୟାଡାମ। ବେଳେ ବେଳେ କଣ
ଓକେ
ହଉଛି କି ଲମ୍ବା ମେଥଡ ବି ବେଳେ ବେଳେ ଯୋଉଟା ରହୁଛି ଆପଣ ତ କହୁଛନ୍ତି ସର୍ଟକଟ ମେଥଡ ଆମକୁ ଟିକେ ଯେମିତି ଆପଣ
ଶିଖେଇଦେବି ଆଚ୍ଛା।
ହଁ ହଁ ସେମିତି ସର୍ଟକଟ
ଓହୋ
ମେଥଡ ଟିକେ କରିବାକୁ ପଡିବ। ଠିକ ଅଛି
ଓକେ
ମ୍ୟାଡାମ, ଆପଣ ବହୁତ ଲେଟ୍ ହେଇଗଲାଣି ଆଜି, ଥ୍ୟାଙ୍କ ୟୁ ସୋ ମଚ୍।
ଓକେ
ଆପଣ
ଥ୍ୟାଙ୍କ ୟୁ।
ବହୁତ ବହୁତ ହେଲ୍ପ କଲେ ନାଇଁ କି?
ଓକେ ହାଇ ଲୋକ ଟାୟାର୍ଡ ହେଇଗଲେ 8:30 ମୁଁ ଟାଇମ ଆଉ ଦେଖିନି।
ଆଜ୍ଞା ଆଜ୍ଞା ଆଜ୍ଞା
ଓକେ ସାର୍।
ଓକେ।
ଓକେ ସାର୍ ଥ୍ୟାଙ୍କ ୟୁ ସାର୍ ୱାନ୍ସ अगेन। तो ମୁଁ स्टॉप शेयर कर दूंगी। ओके सर कैन आई लीव नाउ?
थैंक यू मैम।
थैंक यू।
Thank